Now let's take a look at computer systems and computer programming. So to begin with, what is a computer? So just in the most general sense, a computer is it's a piece of hardware that is designed to execute a set of very basic operations. Okay, and these operations are predefined, they're built into the hardware. But you can tell the computer which operations to execute and in what order and whether to repeat those operations by providing the hardware what is known as a program. So a computer program, which is also known as software, it's a list of the actual operations that you want the computer to execute. And what's really interesting about a computer is that the operations that it performs at any given time are very simple. It's only when you put together a sophisticated list of operations and the order of operations, and you become very clever about how you use these operations, that you can actually accomplish more complicated tasks. So that's the art of software engineering or computer science, is trying to figure out, for a given set of operations that are built into the hardware, how can I solve a problem by coming up with the sequence of operations that I'm going to do. So what is the algorithm? So the algorithm is how you organize these operations to accomplish a task. So, but when you first learn about programming, it's actually very simple. There's only three essential constructs of any computer program, and those are the sequence, those are the decision, and the loop. Okay, and so a sequence is doing something, doing one or more things. A decision is deciding which ones to do next, and then a loop is repeating those. So if you think about a computer program in terms of those three constructs, it becomes very simple to piece them together in order to accomplish tasks. And this becomes very important when you start programming a robot to do something. So let's take a look at a sequence. So this is a graphical interpretation over here of what the program is going to do. So this right here is we're going to put it in the term in a flow chart. That's what this is called right here. So we're going to start the program, and let's say that we had a sequence of things that it's going to do. So we're going to move forward 6 inches, we're going to turn right 90 degrees, and then we're going to move forward 3 inches, and then we're going to end. So if I had a robot right here, and I wrote and executed this program, I would say, okay, start. So it would go forward 6 inches, then it would turn right 90 degrees, and then it would move forward 3 inches. So that's what the robot would do. Okay, so this is a very simple program, but you can actually make the robot do something. Okay, then let's look at the second programming construct. This is going to be a decision. All right, now a decision, what we have here is, this is the flowchart for a decision, and the decision is actually it's actually indicated by this little diamond looking thing. But let's just walk through how this would work. So we start our program, and we're gonna do a sequence, a task. We're gonna say move forward 6 inches, and then a decision is where you say, is something happening? Is there a condition? Okay, so for this example, let's say, is there an obstacle in the way? All right, then the interesting thing about a decision is the decision is always a logical or a logical answer, and the logical answer is either yes or no. Okay, so it's not saying like, what is the number? The answer is not 7 of a decision. It's, is it true or false? Is it yes or no? So it really simplifies the way that you make these decisions. So for example, if I come to this decision, move forward 6 inches, is there an obstacle in the way? If the answer is no, you are going to execute a different sequence, and in this case I would move forward 6 inches. But if the answer was yes, we can allow our program to actually take another path and execute a different set of operations or sequence. So in this case, let's say turn right 90 degrees, move forward 3, turn left 90 degrees, move forward 6. Okay, and then we end. So let's take a look at what that example would look like if I drew this out, and think about how this might be very helpful for a robot. Okay, so let's say this is our little robot over here, and let's say that there's no obstacle in the way. Okay, so we start our program, which is going to be right here. So we're going to start moving forward 6 inches. So we move forward 6 inches, and let's say that that's where 6 inches is. And then it says, is there an obstacle in the way? Okay, so it's sitting right here, and the answer is no. Okay, so it's going to then take this path through the program, and it will then say, okay, I'm going to move forward another 6 inches, and then it stops. And that's the end of the program. So it did make a decision. It didn't affect anything. It just continued to move. But what would happen if there was an obstacle in the way? Now you might be saying to yourself, well, how do I know if there's an obstacle in the way? Well, computers have inputs and outputs, and robotic computers have inputs and outputs in the form of sensors. So they have things such as obstacle detection sensors, so you could have a push, like a button. So if you run into something, the button gets pushed and it says, hey, I saw something there. Or you could have more sophisticated sensors such as infrared sensors or ultraviolet sensors or any sorts of sensors. So the computer in a robot tends to bring information in to make decisions about its environment using sensors. So we're just going to assume that the sensor exists and we don't have to worry about it. So let's take a look at now, let's come along, and now we're going to run that same program. And here's now our green robot. And what we're going to do now is say, hey, there's something in the way. So we're going to have an obstacle right here. So let's just say that there's a big there's a wall or something there. And so I'm going to come along and I'm going to execute my program. So the first thing it's going to do is move forward 6 inches. So it says, okay, I'm moving forward 6 inches, and it stops. And it's sitting right here. So it's gone through the program, it's gone through the 6 inches, and it says, is there an obstacle in the way? And in this situation, there is an obstacle in the way, so it's going to do something else. It's going to turn right 90 degrees. We're going to head down this path right here, and it's going to turn right. So it's going to turn right, and then it's going to move forward 3 inches, and it's going to turn left, and then it's going to move forward 6 inches. Okay. Now look at what happened here. This is in the most simplest form an obstacle avoidance program. It's very simple. It required a decision in terms of to alter the actual program flow based upon some sensor to indicate if there was an obstacle. But look at what happened. I made a robot that went up. If there was an obstacle, it turned and avoided it and then continued on. So in the end, it went a certain distance. It ended up getting here, whether or not there was an obstacle in the way, but I was able to avoid it. So this is a simple program that illustrates what a decision might look like. Okay, so let's take a look at the third construct, and that's going to be loops. So notice in the prior examples, we basically had programs that started and stopped, and you know that usually when you have a program, it runs forever, okay? So how do you keep a program running? Well, you do that in a loop. Now in this little flow chart over here, we're just going to have loop represented as an arrow. Okay, so we start our program, and then we're going to move forward 6 inches, turn right 90 degrees, and then we are going to repeat, and we're going to come back here and continue. Notice that this loop always occurs. So when it always occurs, we call that an unconditional loop. That means it's just going to continually run these instructions. It's just going to sit here and it's just going to run and run and run. So let's go over here and see what our robot would do. Okay, so here's our little robot again. We'll go with the red robot. And it is going to do this. It starts off and it says move forward 6 inches. Okay, so let's say that's 6 inches. Turn right. And now at this moment in time, we have gone through the program, and we are right here. Okay, so we've gone through once, and we're now going to repeat. Okay, so we're going to come back up here, and what do? We're going to move forward 6 inches. So I'm going to move forward 6 inches, and then I'm going to turn right, and then I'm going to repeat. So we've gone through the loop again. So I'll move forward 6 inches, turn right, and repeat. And then I come up here, and I'm going to turn right, move forward 6 inches, turn right, move forward 6 inches, turn right, move forward 6 inches, turn right, move forward 6 inches. So you see what's happening here? We are in a loop where our robot will go in a square forever. So as soon as you hit run in this program, our robot is drawing a square. It's not drawing a square, it's going in a square. So it's sitting here forever, and that's great. So the program's always running, the robot's always doing something, and we are just continually going around in a square. Now you could see some of the powers of loops. So if you created a loop that had different dimensions or different turn radiuses, you could start doing something where you started making a spiral outward. right? I mean, you could kind of see from just the constructs we've covered already, you could do something like that. That would be kind of interesting. Maybe you had a robot that was sitting here and was going to start harvesting a field and moving around like that. Or maybe you wanted to search pattern. You could also see that you could do a loop where you would turn right, turn left, turn right, turn left. So you could do a more methodical search pattern that went back and forth. So with loops give us the power to start building, fully functional programs. There's one more loop though that's pretty interesting. This was an unconditional loop, but let's look at a conditional loop. So what a conditional loop is where you only loop a certain number of times. So I'm going to draw the loop or represent the decision on when to loop using this decision diamond again. And let's take a look at how this is going to operate. So I come along and I move forward 6 inches, and then I turn right, and then I make a decision. Have you done this 4 times? If you haven't, go ahead and loop. So it's going to come this way if you haven't. And if you have done it 4 times, go ahead and end. So what does this do? This is a conditional loop, meaning that it'll only loop it'll only loop based on a condition. So what is this going to do? So if our robot's over here, and you think about our sequence is really the same thing. It's talking about moving forward 6 inches, turn right. Okay, now I'm sitting here, and I've only done that 1 time. Okay, let me erase that really quick. So I turn right, and now what I'm going to do is repeat it again because I haven't done it 4 times. So I come over, turn right. I'm going to do it again. Go forward 6 inches, turn right. Then I'm going to go forward again, turn right. So that's my 3rd time. Then I go over here, turn right, and then I stop. So now at this point, what has our robot done? It has gone in a square, but it only did it once and then it stopped. So that's how I could actually use a conditional loop in order to accomplish this. So that's really it. I mean, it's very simple. That you've just now covered what a flowchart is. I mean, this is very simple. You just have little blocks, and the decision is a diamond. But you can kind of understand this pretty quickly. It's just I'm going to do something. I might do a couple things in a row. I might have a sequence of tasks, and then I might make a decision based on some information about the environment, and I might have a loop. I might repeat that, or I might repeat it a certain amount of times. So those are the programming constructs of any program. Now to get started, one of the best ways to get started is there's an open source program out there called Blockly Games, and this is the purpose of it. I wrote it down here. Blockly Games is a series of educational games that teach programming, and it really is to try to get young students, familiar with the construct of programming, and to start to think about maybe solving problems using these logical constructs such as a sequence, a decision, and a loop. And what Blockly is, it starts with a graphical programming exercise, and it kind of leads up in complexity. So you start with a puzzle, which just shows you how to piece these 3 constructs together. Then there's a maze, and then it goes on to a bird and turtle and all this stuff, and it ends with a particular exercise where you move more into writing a program using text. So it starts off graphical and it ends with text. The reason it's neat is because the graphics used in this are very similar to the way that the LEGO Mindstorms robotics interface works. So it's a really good way to just jump online and say, I'm going to start practicing with this. So let's go take a look at it. So I go out to this website, blocklygamesappspot.com, and I come in here, and what I'm going to do is I'm going to go right to Maze just to get familiar with this. And what you do here is you're given a task to do, a task to accomplish. So you're trying to make this little guy over here go to, you're trying to make the guy go to this little marker. Okay, so what you do is you come over here and you can drag in these constructs. So the constructs that they give you is move forward. So I have this move forward, and if I run the program, it will do something. It will do that. And if I go ahead and say I'm going to do that, I'm just going to run this program, it moved forward, and notice that it only went a little bit. So what I really need to do is the move forward construct only got me halfway there, so I need another one. So watch what I'm going to do. I'm actually going to drag this over, and I'm going to set it right here. Now, it gives you a hint that these need to be put together like a puzzle piece. So notice that they're kind of locking together when I get them close. So now I have 2 move forwards. So let's take a look at, let me reset that, and now I'm going to run the program. So I go 1, 2, and it worked. So I made it. It says congratulations. Now what's interesting is it shows you what the program would have looked like if you would have written it in text, but it doesn't matter. You don't even need to know about that right now. You just need to worry about, can I do this? Now I'm going to cancel that. Look at some of the other constructs that it gave to you. You didn't use them in this program, but you could have turned left, and what it does is it has the ability to change from turn left to turn right, and you'll see that these constructs are more advanced constructs are given to you as you advance through the levels. So there's 10 levels in here, and they get increasingly more difficult. Here's one of the things I always like to do. I'm going to change this. You can change its background to space. So now you're in the International Space Station and you're trying to navigate around. You can also be a panda walking on bamboo shoots. So let's go with the astronaut here. Okay, so let's do the next level. We already have this thing. Let's go ahead and run that program. And I won. Okay, great. Okay, so here's level 2. So I'm going to move. How would I solve this? I want to move forward, then I want to turn left. So I'm going to drag over the turn left, and that's all the options it's giving me. It's really walking me through. It's kind of giving me baby steps. So if I run this program, it's going to go and turn left. Okay, that's great. It didn't work. I didn't get to the end point, but I at least went and turned left. So let's go forward, turn left, and then go forward again, and then turn right. So I'm going to drag that construct over there. So I run the program, turn left, go straight, turn right. And it's showing you which construct that it's actually running at the time. And so it's like, okay, this is fantastic. We're almost there. All I really need to do is move forward again, and I'm good to go. So I run this sequence, and I pass the level. And it shows you what you did. Now, this is still just a sequence. Here's why this is so interesting is I mentioned it was open source, meaning that the people that administer this, which currently it's administered by Google, open source means you can download the code and you can run it yourself, you can modify it, and you can use it for things that you want to do. So what you're starting to see with robotics is that this graphical programming language, there's a lot of applications that are being created that support this, and it's becoming more familiar for other types of robotics. So you'll see a similar thing like this that when we go to the LEGO Mindstorms programming, but you'll also see applications that can be used to control drones or control a Sphero or control different types of robots. So young people can get started with this right away with Blockly, and then you can immediately use that interface or use your knowledge of that interface to start programming real robots. Now, the actual interface for the LEGO Mindstorms is graphical, but it's not exactly using the Blockly puzzle pieces, but it's similar in nature in terms of it's a graphical interface. Okay, so I want to let's go to the next level, and let's see what a decision would look like. So I'm going to continue. Now this one, actually this isn't this is a loop. So look at what we're going to do now. So now I have a loop, and what I want to do is I'm going to drag this over, and I'm going to say, it gives me a condition. Repeat until I hit the end marker, do this sequence. So I'm going to move forward once, and I'm going to repeat that until I get to here. So this is an example of our conditional loop. So if I just run this program, it will go until you get there. So there you have it. And now look at what it did. It showed you the text for it. This is a while loop. You don't need to know what that is, but you can kind of see the text construct or the text way of implementing this. Okay, so let's go. Look at this one. Now we really have some interesting things. It's repeat until this. We got to turn right, turn left. And so this will be kind of where I stop because what I'd like you to do is get some practice doing this. I mean, it's fun, number one, but it just gives you some practice of just getting familiar with this. So how would we solve this? I would go forward, turn left, but then I need to go forward and turn right. And if I stopped there, could I repeat that task? Well, go forward, go left, go forward, go right. If I repeated that sequence, I would probably end up getting there. So why don't we think about this? Let's move forward, turn left. Let's move forward, turn right, and then I want to put that in a loop. So will this work? So let's run the program. I go left, right, left. It's doing it. And you see how it's moving back and forth, back and forth. Okay, so this is great. We're using a conditional loop with more advanced sequences. let me show you what happens if I mess up here. So I'm going to reset this. Let's say that I just messed up a program. So I turned right. Let's run this. Watch what happens. The little astronaut just falls off of the International Space Station. Anyway, that is Blockly Games. So play around with this. It's pretty fun. And like I say, if you go back to Blockly Games, once you get through that, you can. There's the bird game. It's very similar, but it gives you a little bit more complicated tasks to do. You can go on to the turtle. This is another graphical programming. So it's just a series of games that gets you just familiar thinking about things logically, or what we say algorithmically, of trying to solve a problem using the constructs of a computer. Okay, so what is next? We've now looked at programming basics, and we've looked at a little exercise in order to get familiar with those. And so the next step is we really want to start programming our robot, but before we do that, we have to construct it. So the next thing we want to do is look at how you actually construct the robot.